So the project I'm going to be presenting is called Village at Park River. So this is a multi-phase, multi-family project, pretty much transforming this neighborhood in Hartford, Connecticut. Oh, trying to get the slides to move. Sorry about that. All right, so the picture you're seeing to the left here is the site prior demo, which is seeing all the public housing, a 40-acre former public housing site. And the picture to the right is phases 1 and 2 in construction. The design intent is to have 420 units over 6 phases, multifamily, mixed income housing. And here's a beautiful rendering, which was done by Kirk Fromm. So the design is by WRT, as you know. So you're looking at all 6 phases here. We have 6 buildings in phase 1, which will be completed this fall. 6 buildings in phase 2, which will kind of completed spring of next year. And we have 6 buildings in phase 3, which will break ground this fall. And there's also a community building here. And we are currently working on the tax credit application to be submitted fall of this year for phase 4, which will be 5 buildings. So here is like the master plan. So phase 1 here, the 6 buildings will be certified to PHI standards. Phase 2 will be certified to PHIUS plus 2015. Phase 3 to PHI. And phase 4, we are currently working on the energy model. We are actually working on the energy model for PHIUS plus 2018 and having some struggles. We are able to, with some tweaking, I would say, we are able to meet the heating demand and the cooling demand of the project. But we are struggling to meet the source energy criteria, which has been, I know the threshold has kind of tightened for a good reason from PHIUS 2015 to PHIUS 2018, but we yet have to figure this out. So over the 3 phases which have been awarded low-income housing tax credit, that'll give us like 200 units. Phase 4, which will go into submission this fall, will be an additional 60 units. So this is like looking at the QAP of Connecticut Housing Financing Authority. As you can see, there's a good amount of weightage given for sustainable design, particularly passive house design. And we usually like the tax credit application goes beyond the 90% construction documents. It's like a 95. So that gets an added 3 points here. And we also provide about PV for each phase. We've been providing to about accommodate for 33% to provide for site lighting. So all put together, I think it's been a great opportunity to be doing passive house in the state of Connecticut. Here are some pictures in construction, phases 1 and 2. You can see the nearly completed buildings of phase 1. Moving on to some passive house envelope features. So we have used XPS for sub-slab rigid insulation, and then 15 mils Tego wrap for the vapor barrier. The exterior wall assembly is ZIP R12 exterior sheathing combined with R21 batt insulation. The exterior doors here are not passive house doors. Actually, the client didn't like the look of the passive house doors, so we are going with masonite insulated solid core doors. I think it's like a R7 or R9. So we did model that in the energy model. However, as you know, we can't model air infiltration. The windows are passive house rated Alpen windows in the units, and phase 1, we have like a small management space, which also has these about 6 feet by 6 feet passive house rated windows. And at the ceiling air barrier, we chose to use ZIP sheathing. You'll see this detail in a few minutes. So pretty much everything, so they're all low-rise, and all the buildings follow this kind of concept. Everything is within the passive house envelope except the sprinkler room. So here's pretty much captures what I just talked about. Rigid insulation for subslab, which gives us an R20. For most buildings, there are some buildings which are pretty tight. We had to bump it up to an R30. Zip R12 exterior sheathing combined with R21 bat, which gives us about an R33. And the roof is a blown-in cellulose insulation to about a R100. As you see, our passive house air barrier kind of is terminated at the ceiling, and the attic space is excluded from the passive house envelope. Moving on to some mechanical features, the one-bedroom units have wall-mounted heat pumps. And then for the 2- and 3-bedroom units, we have ducted heat pumps. The hot water heater for all units is a gas-fired tankless on-demand system. Each unit has its own individual ERV. This is a PV, which we have one building in each phase, providing to accommodate for this about 33% of site lighting. And the units have their own washer and dryer with a ventless dryer. So the data you're seeing here is coming from the energy model. This is like a worst case building for each phase. And this is building 15 in phase 3 seems to be our tightest energy model. This is phase 3 is PHI. When I say tightest, it's not due to the EUI, it's like our heating demand is getting very close to the threshold. Here is just to bring some discussion to how we had designed the air barrier detail at the foundation. We had designed the stego wrap sub-slab riding up the edge of the slab, under the sill plate, and vertically riding up the exterior zip sheathing. However, GC struggled with this detail, and what's happening as a construction detail is pretty much this. So we're doing the stego wrap. The stego wrap kind of stops under the sill plate, and then there is like a zip tape to bridge that and take it over the exterior zip R12 sheathing, and they're coming back with the fluid applied air barrier to make it a continuous air. So the windows are passive house, as you know, triple glazed. We detailed it to include the self-expanding foam joint sealing tape. However, that was VE'd during the process. I think it's a combination of the GCs not being familiar of the practicality of installing this, and also it's a cost. So on site, the detail actually what happened is it got like closed cell spray foam as the air seal. So this is the passive house air barrier detail I'd mentioned previously. So we're doing this kind of a sandwich system. So we have the zip R12 as the wall assembly, and we're kind of continuing that at the ceiling with the zip sheathing. So for some testing information, so as some of you may have heard at this afternoon's presentation, when Adam Blackman talked about that CHFA requires all testing protocol to be per PHIUS, irrelevant of if the project is getting certified to PHI or PHIUS. That being said, we had to, for these, so the preliminary testing has been completed for some of the buildings, not the final yet. That will be done anytime soon. So for the final testing, we had to do these openings between each demising wall condition, about a 12 by 12 opening for the passive house whole building testing. And also we have like stacked flats. So we had these openings made at the raised porches. So this was happening at every floor at the demising wall. So after the passive house whole building testing is completed, the GC has to come back, patch everything, air seal, fire seal, every location, And then the Energy Star testing for individual unit compartmentalization is done. So that's a bit of a process, but I'm not sure if there's any other option. And preliminary testing, we found that there was a lot of leakage at basically the passive house envelope. There was leakage, air infiltration at the sills. The windows somehow were not adjusted, so that windows had to be adjusted on site. And air infiltration at the ERV vents was a bit of an issue. There was some wood blocking we had shown in the details, so that had to get fixed. And also at the heel of the trusses was a great location where there's a lot of leakage, air infiltration coming in. So yeah, so this is a rendering of a street view. This I think is coming from phase 2. And I would like to conclude by thanking our client, Shirley Adams. Adam Blackburn from Innova is a passive house rater, and Adam Kinkle from Haynes Construction is the project manager from is the GC project manager. And I think we should be having all 3 of them in the audience to make it a more interesting Q&A session.